Good morning and good afternoon, RSGA 6th grade, and whoever decided to watch this video. And welcome to video 5 on our series of STEM Around Us. Imagine a tug of war where both teams are pulling equally hard. Nobody moves, right? Now imagine one team is way stronger. Suddenly, everyone's moving. That's the difference between balanced and unbalanced forces. And it's key to understanding why things move or why they stay still. In this video, we're going to explore Newton's ideas about motion and see how they explain everything from sports to space travel. So let's go ahead and do a quick review. A force is a push or a pull, and we measure it with units called newtons, named after Isaac Newton himself, the scientist who figured out the laws of motion. Forces have size and direction. A big force makes a bigger change than a small force. When multiple forces act on something, we have to look at all of them together to predict what will happen. Balanced forces happen when all forces on an object cancel each other out. Imagine pushing on opposite sides of a desk with equal force. The desk does not move because the forces are balanced. A book sitting on a table? Well, gravity pulls down, the table pushes up equally. Balanced forces mean the object either stays or keeps moving at the same speed in the same direction. No change in motion. Right now, as you're sitting in your chair, you're experiencing perfectly balanced forces. Gravity pulls you down towards the ground with your weight. The chair pushes up with equal force called the normal force. These forces are balanced, so you're not accelerating one way or the other. You're just sitting there. If the chair suddenly disappeared, the forces would become unbalanced, and gravity would accelerate you towards the floor. Hopefully, this doesn't happen, and in the class, remember, all four on the floor. On the other hand, unbalanced forces is where the action is at. The forces don't cancel out. They get a net force, or the leftover force of all forces that are combined. The net force causes acceleration, a change in speed or direction. When you push a shopping cart, your push is greater than friction, which creates unbalanced forces. The shopping cart accelerates in the direction of the net force. The bigger the net force, the more acceleration you get. There are three ways unbalanced forces change motion. First, they can make something speed up or accelerate, like when you step on the gas pedal of a car. Second, they can make something slow down, like you're hitting the brakes. Thirdly, they can change direction without changing speed, like turning the wheel of a car or a ball on a string spinning in circles. In every case, there's a net force causing the change. No net force? Well, no change in motion. The world of sports is full of unbalanced forces. When a soccer player kicks a ball, their foot applies an unbalanced force that accelerates the ball. When a basketball bounces off the floor applies an upward force that changes the ball's direction. When a baseball bat hits a ball, the huge force from the bat overcomes the ball's motion, and it sends it flying in a new direction. Athletes intuitively understand forces, and that's the simple science behind the moves. Rockets and space travel. Rockets are the ultimate example of unbalanced forces. On the launch pad, gravity and the rocket's weight create a balanced force downward, matching the launch pad pushing upward. But when the engines fire, they create thrust, an upward force. When thrust becomes greater than weight, forces are unbalanced, and the rocket starts to accelerate upward. The more powerful the engine, the greater the net force, and the rocket accelerates off into space. Understanding balanced and unbalanced forces is critical for so many careers. Aerospace engineers calculate exactly how much thrust a rocket needs to escape Earth's gravity. Automotive engineers design suspension systems that can balance forces so you can enjoy a smooth ride. Sports equipment designers design and create better gear by understanding how forces affect performance. Even theme park designers use force analysis to design rides that are thrilling but safe. Forces are at the heart of engineering. Now that you understand a little bit more about forces, hopefully, as you're observing things in the real world, you could start seeing these things apply themselves in our lives. I mean, go to the grocery store and check out those shopping carts. Look at the shelves. Watch what happens when somebody accidentally knocks over a couple of cans of baked beans. And look at all the forces at play.